Hello people, welcome to my channel Amrit Bro, where I talk about science, technologies, business and many more. Today, I'm going to talk about the actions that are happening around the world to achieve nuclear fusion power for the clean future. I have already made a video about the definition of nuclear fusion, where you can get basic insights about the fusion process. You can watch this video by clicking on the link in the description. For now, let's move forward by quickly recalling the concept in the fusion process. Nuclear fusion is the process by which nuclear reactions between light elements form heavier elements happens, releasing huge amounts of energy. This is the same process that powers the sun and other stars. Nuclear fusion has been considered as a potential source of clean and abundant energy for decades, but it is very difficult to achieve on Earth. To create fusion, we need to heat up a gas of hydrogen isotopes, such as deuterium and tritium, which are also considered as the fuel for the nuclear fusion process. And for the reminder, deuterium is heavily available in the ocean, but tritium is quite rare or exists only in limited amounts on Earth. It can be mined from the moon in future. Anyways, back to our topic. To create fusion we need to heat deuterium and tritium over 100 million degrees Celsius, which is hotter than the core of the sun. At this temperature, the gas becomes a plasma, a state of matter where electrons are separated from nuclei. Then we need to confine the plasma in a strong magnetic field and squeeze it until the nuclei collide and fuse together, releasing energy. Tokamak can be used for the fusion of the hydrogen isotopes. What is tokamak? A tokamak is a type of magnetic confinement device used in nuclear fusion research. It is a donut-shaped chamber with a strong magnetic field that confines the plasma, or hot, ionized gas, at the center of the chamber. The plasma is heated by radio waves or by electric currents, and it is held in place by the magnetic field. The tokamak is the most promising type of magnetic confinement device for commercial fusion power plants. Projects for nuclear fusion in the world. 1. Joint European Torus. There are several projects around the world that are trying to achieve fusion energy. One of them is JET, or Joint European Torus, located in the UK. It is a predecessor to the ITER project. JET is the largest and most powerful tokamak-based fusion reactor in operation today. It has been running since 1983 and has achieved several world records in fusion performance. In February 2022, JET broke its own record by producing 59 megajoules of energy over 5 seconds, which is more than double what it achieved in 1997. 2. ITER. The International Thermonuclear Experimental Reactor, ITER, is a major international collaboration to build a tokamak that can demonstrate the feasibility of nuclear fusion power. ITER is currently under construction in Cadarache, France, and is expected to be completed in 2025. It will use a tokamak or reactor. If it is successful, it will be a major step towards the development of nuclear fusion power. However, there are still many challenges that need to be overcome before nuclear fusion can be used to generate electricity on a commercial scale. 3. Spherical tokamak for energy production. Another promising project is SPARK, or Spherical Tokamak for Energy Production, which is being developed by MIT and Commonwealth Fusion Systems in the US. SPARK is based on a different design of fusion reactor called a spherical tokamak, which has a smaller and more compact shape than conventional tokamaks like JET and ITER. SPARK plans to use high-temperature superconducting magnets to create a stronger magnetic field and achieve higher plasma pressure. SPARK expects to produce 50 to 100 megawatts of power for 10 seconds by 2025. These are just a few examples of some projects happening around the world for nuclear fusion power using magnetic confinement, but there are other projects as well, which use inertial confinement, which is another method for fusion power. For example, National Ignition Facility of USA and LMJ project of France. Challenges. There are many challenges for harnessing nuclear fusion power successfully. Here are a few of the most important challenges. 1. The high temperatures and pressures required for fusion. Nuclear fusion requires extremely high temperatures and pressures in order to overcome the repulsive force between the nuclei of atoms. These temperatures and pressures are far beyond what can be achieved in any laboratory setting. 2. The need to confine the plasma for long periods of time. The plasma in a fusion reactor must be confined for long periods of time in order to allow the fusion reactions to take place. This is a difficult challenge because the plasma is very hot and can easily escape from the confinement system. 3. the need to find ways to produce and store tritium. Tritium is a radioactive isotope of hydrogen that is used as fuel in fusion reactors. Tritium has a short half-life, which means that it decays into helium-3 over time. This means that tritium must be produced and stored on-site at fusion reactors. 4. Making fusion power economically competitive. Fusion power is still in the early stages of development, and it is not yet clear whether it will be economically competitive with other sources of energy, such as coal, natural gas, and nuclear fission. However, there is a lot of research and development going on in the field of fusion power, and there is hope that it will eventually become a viable source of energy. Conclusion. Nuclear fusion is a promising source of clean energy that could potentially provide the world with a virtually limitless supply of power. However, there are still many challenges that need to be overcome before fusion power can be commercialized. These challenges include developing materials that can withstand the high temperatures and radiation levels of fusion reactors, finding ways to produce and store tritium, and making fusion power economically competitive with other sources of energy. Despite these challenges, there is a lot of research and development going on in the field of fusion power, and there is hope that it will eventually become a viable source of energy. If fusion power can be commercialized, it could have a major impact on the global energy landscape, helping to reduce our reliance on fossil fuels and combat climate change. So, what do you think about these achievements in the field of nuclear fusion? Will the world be able to experience its successive touch by 2050? Please, let me know in the comment box. Thank you for watching, and if you liked the video, then please give thumbs up and do not forget to share it with your friends and families. For those of you who have not subscribed to my channel, please do subscribe to it now. I will catch you again in another video. Till then, wishing you all a good time ahead. See ya, people.